Hi, welcome to the Mechanics Past Paper Solution. This is Edexcel IAL, January 2017. So let's start. Question number 1. A train moves along a horizontal track between two stations R and S. Initially, the train is at rest at R. The train accelerates uniformly at half meter per second square from rest at R until it is moving with the speed of 15 meter per second. For the next 200 seconds, the train maintains a constant speed of 15 meter per second. The train then decelerates uniformly at 1/4 meter per second square until it comes to rest at S. Find the time taken by the train to travel from R to S and the distance from R to S and the average speed of the train during the whole journey from R to S. So the situation is you have a station R where a train is at rest and then it is accelerating A1 half meter per second square, and then it accelerates, so that means velocity is increasing until at some point the train reaches at the speed of 15 meter per second. This is the speed, and then the train keeps moving with the same speed till 200 seconds, and then it starts decelerating and reaches at station S where the train comes to rest. And in the last interval the train is decelerating, so acceleration is minus 1/4 meter second minus 2. So you have three interval. The first interval are, I just call this point as A and this one is B. So you can say that from R to A you have accelerated motion, train is accelerating. From A to B you have uniform motion, velocity is not changing. And from B to S you have accelerated motion, or you can say decelerated motion. So for part A you need to find the time taken by the train to travel from R to S. So you need to find the time, the total time. So one method is you can use equation of motion to figure out time in the first interval and the last interval and then add these up to get the full time. So let's see, we assume that the time for first interval is t1 and the time for last interval is t3, because this is the third interval, and this 200 second I'm assuming this is t2. So for t1 you have initial velocity 0, final velocity 15, and acceleration is 1/2 or 0.5 meter second minus 2. So you can use the first equation of motion, v is equal to u plus at, to figure out the time. So t is equal to v minus u divided by a. So I will call it t1. That means 15 minus 0 divided by 0.5. So clearly t1 is, the 0.5 is 1/2, so 1530 second. This is t1. Similarly, you can work out for t3. For t3, so your initial velocity for the last interval is 15. It is because train is moving with constant speed throughout the second interval. So when reach at B, the velocity of the train will be 15. So initial velocity is 15 and the final velocity will be 0 because train is coming to rest at S, and acceleration is minus 1/4 meter per second, or 0.25 if you wish to say. That means T3 is equal to V minus U over A. That means 0 minus 15 divided by 0.25, or 1/4. 1/4 multiplied with the 15, you will get T3 is equal to 60 seconds. So the total time of journey, so the total time T is T1 plus T2 plus T3. So meaning 30 plus 200 plus 60. That means total time is 290 seconds. This is the time to find out, to cover the distance between R to S. Same question you can do with the help of the graph. If you wish, you have two options. So I will just draw the graph. So you can say that this is velocity axis and then time axis. In the first interval, train is accelerating. And then moves with the constant velocity and then decelerate. That means you have till here, this is the time T1, and then it's better not to call T1. This is R, and I'm calling this as point A, and this is point B, and this is S. So from R to A, you have time T1. A to B, you have time T2, and then T3. Clearly, this velocity is 15. This is velocity, and this is time graph. So if you find the gradient of R till this point, if you find the gradient, so the gradient of this interval, the first interval, is the gradient is rise over run, and rise is 15 divided by run. Run is T1, which is the time taken by the train, and the gradient, this is velocity time graph, and the gradient is acceleration. So you can put gradient is your acceleration for the first interval, which is 1/2. So 1/2 is equal to 15 divided by T1. If you solve this equation for T1, so T1 would be equal to 30 seconds, as in the first case. And for the second time, that means T3, you need to figure out gradient of the last line. That means gradient of this line, and the gradient of second line, the gradient is rise over run. In this case, rise again the 15, and run is the time T3, and acceleration is 1/4. So 15 over P3, and clearly T3 will give you 60 seconds. So you have T1, you have T3. Now T2 is 200. That means this from A to B, this time is 200. So the total time T is 200 plus 60 plus 30, 290. So it's your choice whether you choose graph to calculate the time, or you can use direct equation of motion if you understand the situation for the whole motion. So you can choose any one of the method. So the total time from R to S is 290. Okay, part B. Find the distance from R to S. Again, you can use equation of motion, or you can use graph to find the distance, because for velocity time graph, VT graph, if you have a graph something like this or any shape, then area under the graph gives you the distance. So for this situation, this is the point A, point B, station R and S. So the distance traveled by R to S is the total area under the graph, and you have two choices. You can divide the whole region into two triangles, like you can assume this is the triangle, another triangle, first triangle, second triangle, and this is the rectangle. So you can figure out three different areas, one triangle formula, two areas for triangle and one for rectangle, and you can add them up to find the distance. Or you can use area formula for area of trapezium, and trapezium formula, which is for me it is easy. So area of trapezium is half of A plus B into H. And what are these A, B, H? So you can see a trapezium is a geometrical figure in which two lines are parallel and two are non-parallel. So the parallel sides have lengths A and B. Which one A, B is your choice. You can call one of the parallel side is A and B. So A and B are length of parallel side, and H is the distance between parallel side, that means vertical height. This is H. If you see this parallel side, this length is 200, and the opposite parallel side is this much, and you have found this as 290, and the height is 15, because this is velocity graph. So you can use formula for distance from R to S. So the distance is half of A plus B. A plus B means 200 plus 290 times of 15. So if you add these two, multiply by 15 divided by 2, so your distance would be equal to 3675 meter. So this is the distance traveled by the train. Okay, part C, the average speed of the train during the journey from R to S. Whenever they talk about average speed, so average speed is total distance divided by time taken. So it is your average speed. So the total distance we have found 3675 divided by total time is 290. So your average speed during the whole journey is 12.67, or you round it off and you say 12.7 meter second inverse. Question number 2. A particle P of mass 0.5 kg moves under the action of a single constant force. This is F. Find acceleration of P. So a straightforward question. F is given. Need to find acceleration. Mass is 0.5 kg. So you can say that F is equal ma. So acceleration is equal to force divided by mass, and the force is 4I no, it's not 4I, it's 2I plus 3J divided by mass. Mass is 0.5. So you can say that this 0.5 you can split under each component. So 2I divided by 0.5 plus 3J divided by 0.5. So finally your acceleration would be equal to 4I plus 6J meter second minus 2. So this is your acceleration. At time t seconds, P has a velocity v meter per second. When t equal to 0, v equal to 4I. Find the speed of the P when t equal to 3. So you know that the general formula for velocity after time t, so v at time t, v is equal to u plus at. This is the velocity after time t, and at t equal to 0 the initial velocity is 4I. So I can say that v is 4I plus acceleration we have found in the previous part, 4I plus 6J into t, and t is 3. So if you multiply this 3 with the bracket, you have 4I plus 12I plus 18J, and then v is equal to, you can take I common, so 4I plus 12I is a 16I plus 18J. This is the velocity of the particle, or velocity of the particle. But they are not asking finding the velocity, they are asking you to find the speed, and speed is magnitude of velocity. Magnitude of the velocity. So the speed is the magnitude, that means 16 square plus 18 square root. So speed will be equal to 24.08 or 24.1 meter second minus 1. This is the speed after time, after t equal to, or at t equal to 3. Given that P is moving parallel to the vector 2I plus j at time t equal to t, find the value of t. Okay, so let me just clean this. Yes. So given that P is moving parallel to the vector 2I plus j at t equal to t, find the value of t. So at velocity at t equal to t is v equal u plus a into t. That means 4I plus acceleration 4I plus 6j times capital T. Once you multiply and separate the I and j component, so you have 4 plus 40 I and 60j. So you separated I and j component. This is velocity at time t. At that moment, the particle is moving parallel to this vector. So remember, if you are given two vectors, vector a1i plus a2j, and you have another vector b, b1i plus b2j, and if you are told that both vectors are parallel, it is only possible if the product of coefficient of I of one vector with j of the other and j of the first, I of the second. That means if they are parallel, that means a1 b2 must be equal to a2 b1. This is one of the most important condition for two parallel vectors. And in our example, our velocity at capital time t is 4 plus 40 I and 60j, and the particle is parallel to this vector. That means if you multiply I coefficient of our vector 4 plus 40 with the j coefficient of the second vector, meaning 1, equal to j coefficient of our vector 60 multiplied by I coefficient of first vector of the given vector, that means 2. And now it's clearly it is equation only in terms of t. You can solve this equation for t and just make t as a subject, so t would be equal to 1 upon 2. Question number 3. Two forces P and Q act on a particle at point O. Force P has a magnitude 6 Newton and the force Q has a magnitude 7 Newton. The angle between the line of action of P and the line of action of Q is 120 degree as shown in the figure. The resultant of P and Q is R. Find the magnitude of R. Okay, so these are two forces acting at point O, 6 and 7 Newton. Angle between P and Q is 120 degree. This question is all about the understanding of adding two vectors. And if you recall, the addition of vector is the head of one vector is joined with tail of the second. So you can visualize the resultant R as if you can visualize that the vector OP is joined at the head of Q. So you can say that so this is your vector OP or the 6 Newton vector. Clearly your resultant would be this. So this is your resultant R, and you need to figure out this R. So what about the angle? See, and this is all about a triangle. So the easiest method to figure out R is sine law and cosine law. And most of the time we use cosine law to figure out side of a triangle. So if we need to find the R, one of the side of the triangle, that means we need its opposite angle. We need this angle. This angle we need. So how do we figure out? You can say that if you extend the 6 Newton vector in backward direction, something like this, So this angle is 120 degree. Okay, because these are alternate angle, 120 and 120. This is 120, and if this is 120, this angle should be 60 degree. Now we have angle. If we have angle, we can figure out r, because two other sides are given. So you can say that using cosine law, you can write r square is equal to 7 square plus 6 square minus 2 into 7 into 6 cos of angle opposite to r. In this case, this is 60. So once you solve this for r, after taking square root, r would be equal to 6.6 Newton. This is r. Okay, this is 6.6 Newton. The angle between the line of action of r and the line of action of p, meaning you need to find this angle. This is theta that you need to figure out, question mark. And this angle would be equal to angle inside the triangle, because again alternate angle. So if you can figure out the value of the inside angle, your required angle would be as same as this one. And in order to find this angle, we generally use sine law. So sine law is sine of the angle, sine of the angle that we need to find, sine of, let's say I'm calling it theta, this is theta, sine of theta divided by opposite side, 7 Newton. So 7 is equal to, we have another angle of 60 degree inside the triangle, so sine of 60 divided by opposite side, in this case r, and we have figured out r is 6.6 Newton. Now you have just one unknown in this equation, which is theta. So you can say that theta is equal to sine inverse of 7 times of sine 60 divided by 67.5, and theta would be equal to 67.5 degree. Question number 4. A plank AB of mass 20 kg and the length 8 meter is resting in a horizontal position on two supports at C and D, where AC is 1.5 and DB is 2 meter. A package of mass 8 kg is placed on the plank at C as shown in the figure 2. The plank remains horizontal and in equilibrium. The plank is modeled as a uniform rod and the package is modeled as a particle. Find the magnitude of the normal reaction. So in this case, you know that there are two pivots on which the plank is resting. So at D you have a normal reaction RD, and at C you have RC. Other than these normal reaction, there are two forces acting on the plank. One is at the center, weight of the plank, and mass is 20 kg, so weight would be 20 g. And the particle resting at C has mass 8 kg. That means you have another force acting at C downward. This is 8 g. So in order to find the normal forces, it's our choice that we can figure out the normal reaction considering either C or D as a pivot and finding the moment around that point. So we can choose D as a pivot or C as a pivot. So if you say moment about D, if you're taking moment about D, that means there will be no moment due to RD because it is passing through the D. I have three forces, RC, 8G and 20G. And if you write clockwise moment and anti-clockwise moment, so you say that for 20G about D, the moment of 20G, that means you need this distance. This is the moment arm. And clearly, this 20G is passing through the center of gravity. That means the whole distance is 4. And out of 4, this is 2. That means this is 2 meter. So this is anti-clock, 8G also anti-clock, while RC would be clockwise moment. So anti-clockwise moment due to 20G is 20G times 2 plus we have another anti-clockwise moment due to 8G, and 8G times distance. This is 2 and this is 1.5. So 4 minus 1.5, this distance would be equal to 3.5. 4 minus 1.5, this is, no, sorry, we don't need this distance. I'm sorry, because we are taking D as a moment, so we need from C till D, we need this distance. So the total distance is 8 and this is 2. So 8 minus 2 is 6. So from A to D, we have 6, and from A to C we have 1.5. That means C to D is 6 minus 1.5, which is in fact 4.5. So 8G times 4.5 equal. So these two are anti-clockwise moment. What about clockwise moment? Clockwise moment is due to RC. So RC times, again you have a same distance because P, the particle P and C are at the same point. So again you have a same distance, 4.5. And clearly you can make RC as a subject. RC, separate RC from the equation. If you send 4.5 underneath these and you use value of G 9.8, so RC would be equal to 165.68, or you can say that 166 Newton. This is RC. And between the plank and the support RD, that means you need to figure out RD. So for RD, you can say that if you resolve vector vertically, so RC plus RD, upward forces must be equal to downward forces. So RC plus RD must be equal to 8G plus 2G, that means 28G. So RC is 28G minus RC. If you put G 9.8 and This is RD. So RD equal 28G minus RC. So RD would be equal to 109 Newton. The package is now moved along the plank to point E. When the package is at E, the magnitude of the normal reaction between the plank and the support at C is R Newton, and the magnitude of the normal reaction between the plank and the support D is 2R Newton. Find the distance AE. Okay, so situation is this package or this particle is no more at C. It is moved somewhere at point E in a way that planks remain horizontal. So I am assuming this is the new position of the particle, and this point is E, and this E is x unit away from A. This is x because we need to find distance from A. That's why I assume x unit from A. This is the point E. Okay, so in this case we have normal reaction at C, which is upward, and this is R C, and this is RD. But they are saying at that moment C has a normal reaction R and D has a normal reaction 2R. So RC is equal to R and RD is equal to 2R. So we have R upward and 2R upward, and of course weight of the particle 8G downward, and weight of the plank at the center 20G. And we need to figure out distance x. So first of all, we resolve forces in a vertical direction so we can figure out value of R. So this R is not the value of the magnitude of the normal. This is resolving of vector in vertical direction. So upward forces are R plus 2R at C and at D, plus downward forces 28G. That means 3R equal to 28G, and R is equal to 28 upon 3G. This is the value of R. Keep this value in your mind. Now, if you need to find the distance, so we need to take the moment, the clockwise moment and anti-clockwise moment. And again, it is our choice. We can choose C as a pivot, D as a pivot. We can choose B pivot or A as a pivot. So we will always get same answer. The only thing that you need to understand the pivot distance from the force. So what I'm doing here, I am considering moment about A. So moment about A. So for moment about A, I have two clockwise moment and two anti-clockwise moment. Meaning, due to 8G, the rod is going to rotate clockwise, and due to 8G, it is also going to rotate clockwise. While due to R, it is going to rotate anti-clock. This is also anti-clock. So if you write anti-clockwise moment, so due to force 2R, 2R means normal reaction or at D. 2R, you need the total distance. Clearly, the whole distance is 8 and this is 2. So from A to D, this is 6. So 2R times of 6 plus moment due to force at C, which is R, times of pivotal distance, which is 1.5. So from R to A is 1.5 equal to clockwise moment. So due to 8g, 8g is this, and this distance we have assumed this is x plus 20g, and 20 is at the center of the rod, so this distance is 4. And now you can say that, so 6 times of 2, 12r plus 1.5r, that means 12 plus 1, 13.5 r is equal to 8xg plus 4 times 2, 80g. And you have value of r because this is 13, this is 13.5, I guess 612, yeah, this is 13.5, 13.5 r equal to this. So we have found r, which is 28 by 3g. You can put these values in place of r and can make x as a subject. So x would be equal to 5.75 meter. So this is the distance from between A and E. C, state how you have used the fact that the package is modeled as a particle. So because package as a particle means the weight is acting at the center of the package, that means center of gravity. This is our assumption for part C. So weight of the package is acting at a single point. Thank you very much for this video. Have a nice time.